Hey guys, welcome. This is 1.2 video. So just to let you know, the way we want to start our notes is we always want to start with our headings. So we're actually going to write this at the very top of our page, 1.2 points, lines, and planes. And so our objective today is to understand the basic terms and postures of geometry. I'm warning you right now, there is a lot of vocab in this section, so this is going to take a little bit longer. Okay? So the video might be a little short compared to what you need to actually write. So just letting you know that might happen. So let's go ahead, and I'm using the online textbook, and so you guys have access to this and we'll get you guys into that. So let's go ahead and jump into our first set of vocabulary. Okay? So these are the three foundational pillars of geometry: points, lines, and planes. Okay? So what I would like you guys to do is go ahead and write all of this down. So this box, and this box. If you want to just write it exactly like you see it, that'd be perfect. A point is pretty basic, but it does have no size. It just indicates a location, but does not occupy space. A line goes on infinitely in two opposite directions, and it's very important that we know that it's contained by infinitely many points. Typically, we name a line by using 2 points on it, A, B, and we even put a little line above it, if you see right there. Okay? I recommend pausing the video, writing it down, and then listening to what I'm saying. It is usually the best option for you. Okay? And then a plane. A plane is actually very similar to just kind of like a sheet of paper where it is a flat surface, but it would be extending in all different directions. It has no thickness. I know paper technically has a thickness, but it almost seems like it has no thickness. And within the plane, there contains infinitely many lines. And then over here, we see a plane, and we actually label planes by using 3 letters that are non-collinear, which you don't know yet that means yet, but we will be talking about that in just a second. All right, so get those down, and let's move on to our next set of items, and that is going to be right here, collinear points. So points that lie on the same line are collinear. If you look at this example right here, R, Q, S, those are collinear. They lie on the same line. Next we have points and lines that lie in the same plane are called coplanar. So please write both of these down. And coplanar, well, that means they lie in the same plane. So you see R, V, Q, S, they all lie on that plane. We could call that plane also P right down there in the corner. Notice T and N down there are not on the plane. They're almost like they're shooting through the plane, but they are not on the plane, so they are not coplanar to the other ones. Okay? Again, we're going to get a lot of practice with this vocab, but these are crucial words that we're going to be using every single, not day, but most of our lessons. So here we go. Moving on. All right. Oops, forgot to erase that. Here we go. Our next vocab word is space. So space is just a set of all points in 3 dimensions. I'm not going to have you write that one down. It's just kind of, we don't talk about it a ton, but that's what space is. It represents all those different points in our 3-dimensional place. We call it space. So there you go. What I do want you to write down is the following box right here, and I'll move my face right there. So these are definitely very important, so you want to write down this whole box. So go ahead and pause it, write it down. Okay, so we'll go over these real quick. A segment, so a segment is kind of like a line, but it has 2 endpoints. It doesn't go on infinitely in both directions. And notice we label it by using the points. Doesn't matter which way we read it, A to B or B to A. But notice we do draw a line above it, and it doesn't have arrows on it. It just stops. A ray is kind of like a ray of sunshine. It starts at one endpoint, and then it goes on infinitely in one direction. And so this would be example, starts at A and goes on to B infinitely. Now it's very important that when we draw the line above it, we show the ray is going towards the direction that goes on forever. Notice the arrow is above the B because towards the B is where it is headed. Okay, so a ray. Opposite rays, now you're looking at this picture and you're like, Mr. Smith, that looks like a line. Are you dumb? Well, we aren't dumb. You could actually call a line by two opposite rays, where they might have one starting point and they go in opposite directions forever. So a lot of times lines can sometimes be called opposite rays. The reason why we get into this is because we're going to get into more vocabulary that kind of helps break this up. Okay, so this would be made by CA. Notice the A has the arrow over it because it's going the A direction, and CB because C has the B has the arrow because it's going in that direction. Okay. Let's move it along. So you got that all written down. Like I said, I'm sorry, a lot of vocab in the first couple chapters. All right. Postulate or axiom we have is an accepted statement of fact. Okay. So a lot of times we're going to have postulates, and we don't necessarily need to prove them. We just accept them. This is going to be truth to us. So it's kind of like a weird thing. We get into some sort of weird logical argument, but we just take these, whenever it's a postulate or axiom, we just take these in geometry and we say, we hold these to be true. We don't need to prove them. We will have theorems which are proved, but these we just say, these are true. Okay? And here's our first postulate right here. Through any 2 points, there's exactly one line. So that's like saying from one place to another place, the fastest way is a straight line. So a lot of people agree with that. So go ahead and take note and write that one down. Let's move on to our next one. We have, I think, 4 of these. Okay, you don't have to write this one down, but in intersections where we call 2 lines meet. So you don't need to write that one down. That one's pretty simple. All right, next postulate. And again, we don't remember these postulates by their number. They're just numbering them because they can. If 2 distinct lines intersect, they intersect exactly 1 point. That's pretty common. Again, I don't think that's one we have to write down, actually. That one's pretty basic. So let's kind of continue to march on. All right. This one is also very similar. If 2 distinct planes intersect, they intersect exactly 1 line. Now, I really do highly want you to write this one down. And that's because where 2 planes meet, they form a line. And here's the line that they meet. We'd actually label that line ST. Notice has the arrows over it. Where 2 planes meet, they're going to form a line. Okay, and that is a popular one that we'll use often. And I believe there is one more. If not, I think maybe we finished it. And yeah, here's our last one. Okay, and this one I kind of alluded to earlier. And this is through any 3 non-collinear points, which means 3 points that could not make a line, then there is a plane. Okay, so notice that R, Q, S, these 3 points are non-collinear. There's no way all 3 of those points would fit into one distinct line. They're all out of place. So I could use those to label the plane, or a lot of times if they have a letter in the bottom corner with no point, we can label the plane plane P, or we could label it plane RQS. So today's all about labeling. Let's get a few examples real quick. I'm going to pause the video so I can speed it up. Oh, make sure you write that postulate down. Okay, we're going to do 4 quick examples, which means you have to do some writing, and I apologize, but here we are. So I'm going to move my face back over here. And I have a quick one. It says, what are 2 other ways to name RS? Here's RS. If you draw this picture and the question, and we're going to label this as question 1 on your notes. What we would do 2 other ways, well, see we have Q in there, so we could actually label this as RQ. Again, we're going to put the arrows above it. Or we could also name this QS. Okay, those would be 2 other options. And that's it. Pretty simple. Oh, the lights just went out. Whoa, this is cool. I'm like in the dark, and I'm just like, what's up? But you can kind of see me still. I'm going to go with it. Kind of creepy. I'm in like a room that's all dark. So, anyhow. Another thing we could label this line, just 1/3 one, is you see this little L right here? So we could actually call this line L and a little cursive line, so that's another way we could do it. Okay, let's move on. Feeling real creepy in here. I'm going to pause it and speed up to the next problem. Okay, we're back with problem number 2. If you could write it down, draw the picture. EF and FE form a line. Are they opposite rays? Okay, well, EF, so we're going to, that means starting at E and going towards F. There we go. And then I'm going to change my color here. F, starting at F and going towards E. Okay. Are they opposite rays? Well, do they have a common endpoint? They do not. So these are not opposite rays. See, they would overlap. So no, or let's say not opposite rays. Opposite rays would have the same endpoint. You can tell my handwriting on here is super good. It's getting better, you know? Every year it gets better, I think. I don't know. Okay. So, not opposite rays. If they would have the same endpoint here. We have two different endpoints, so not opposite rays. Alright, next one. Okay, and here we go. This is problem 3. Go ahead and write that down and picture. These pictures sometimes are difficult to draw, but do the best you can. What are the names of two lines that intersect in BF? Okay, so here's the line BF. So what planes would intersect it? Okay, well, we have this plane right here in the front, just like that. And then it looks like we also have a plane in the back right here. Okay, so those would be our two planes. How do we name planes? We have to use 3 non-collinear points. So we could call it plane, so that blue plane here, we could call it BFE or AEF or AFB. There's a lot of different options. Any of the 4 points in the front, we can just use 3 of them because they definitely do not have all on the same line. So plane AEF, and then we could also say the plane in the light blue back here, which would be plane, we could say BCG or GFC or whatever we want. We'll go BCG. Okay, so that line intersects between those two planes. All right, and last one. All right, you guys are troopers for making it with me again. A lot of vocab in the first couple chapters here, so bear with us. What plane contains N, P, and Q? Shade the plane. So let's go ahead and just identify the points. Here's N, P, and Q, and it looks like it can't be the front plane or the side plane because N would not be a part of the side and Q would not be a part of the front. So it appears we're going to go ahead and shade. I'm feeling, I like that sky blue. It is going to be this bottom plane right down here. Okay, so notice that plane, all 3 of those points are on that plane in particular on the bottom. Okay? Alright, that is all. Over and out. I actually have to hit the over and out button or it doesn't work.